Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Astronomers were excited to discover the interstellar object last year. It was named Oumuamua.
In 2017, astronomers discovered an unusual object speeding through our solar system. It was named Oumuamua, which means scout or messenger in Hawaiian. Oumuamua's path through our solar system was unlike anything we'd seen before. It didn't follow a predictable orbit, and it didn't leave a trail of gas or dust behind it. It was as if it were on a mission to explore our solar system. What if we're not alone in the universe? And why has it suddenly returned? Join us as we reveal Neil deGrasse Tyson's frightening revelation about the unpredictable interstellar object. The feared return of Oumuamua. Since its surprise arrival in the solar system in 2017, the interstellar object Oumuamua has puzzled scientists. A duo of American astronomers now think they have solved one of the space rock's lingering mysteries. First thought to be an asteroid, later recast as a likely comet, and by some even considered a possible alien spaceship, the 200-meter space object zoomed through the central solar system in late 2017. During its brief visit, the rock approached Earth within 24 million kilometers and disappeared a few weeks after its discovery. Observations made within this short period of time soon proved that Oumuamua was on what astronomers call a hyperbolic orbit, a boomerang-shaped trajectory that indicated the rock is not native to our solar system, but was only passing through the sun's neighborhood and would never be seen again. But it's back. The first interstellar body ever observed was a sensation, prompting astronomers all over the world to bury themselves in the available data to learn all there was to learn about the object. One of the questions that scientists struggled to answer had to do with Oumuamua's speed, which seemed to increase as the rock rounded the sun. Large bodies, such as planets and stars, can give smaller objects, including comets and asteroids, a gravitational kick that speeds them up. But in the case of Oumuamua, which at 87 kilometers per second cruised 3 times faster than an average solar system comet, these gravitational kicks couldn't explain the observed acceleration. This acceleration swayed many scientists to conclude that, rather than an asteroid, it must be a comet. Comets in the solar system receive additional momentum from the water and dust that evaporate from their icy nuclei as they warm up close to the sun. These comets, however, are famous for their spectacular tails that light up as a result of the outgassing process. And it showed no signs of a tail. Some believe Oumuamua is an alien spaceship, but how do we know that it was an outer space object and not some rogue Kuiper Belt object? Neil deGrasse Tyson expresses concerns about Oumuamua. Neil deGrasse has revealed the first ever tangible evidence of the tick object from interstellar space that came to visit our solar system, Oumuamua. This interstellar object has sent shockwaves across the landscape of space research. The brisk autumn night of October 19, 2017, at the Haleakala Observatory in Hawaii, Dr. Robert Warwick, a postdoctoral researcher, was engrossed in the data pouring in from the Pan-STARRS 1 telescope. Then, like a cosmic whisper, he noticed something extraordinary, an anomalous object hurtling through the inky depths of space. This object, later baptized Oumuamua, defied all known precedents. A name born of Hawaiian heritage, evoking the notions of a scout or a messenger from afar arriving first, initially puzzled scientists. Its trajectory hinted at cometary origins. Yet as it drew nearer to our sun, it refused to exhibit the typical telltale signs, a coma or a tail typically associated with comets. Instead, it presented itself as a rust-red, elongated object, somersaulting through the cosmic abyss at a velocity that seemed to mock the laws of nature. This discovery not only captivated the scientific community, but also ignited the collective curiosity of people worldwide, uniting humanity in fascination for this celestial wanderer. A puzzling journey. Imagine Oumuamua's journey through our solar system as a cosmic riddle, one that sent astronomers on a captivating quest for answers. This traveler challenged everything we thought we knew about celestial bodies. Its peculiarities were a conundrum that left us pondering. Why did this object sport an elongated shape, reminiscent of a cigar or pancake, instead of the usual spherical or oblong form of asteroids or comets? What force set it twirling in a rapid spin, completing a full rotation every 7.3 hours? And the most perplexing puzzle of all, why did it gain speed as it distanced itself from the sun in seeming defiance of gravity's laws? These questions ignited a fevered pursuit of knowledge. Scientists scrambled to decipher the puzzle that Oumuamua embodied. Telescopes around the world pivoted their lenses to capture every glimpse of this interstellar drifter. Space agencies, including the venerable NASA, raced against the clock, hoping to collect as much data as possible before it vanished into the cosmic unknown. But what's the nature of Oumuamua? Oumuamua is striking. Because Oumuamua's brightness changed periodically by a factor of 12 and varied asymmetrically, it was assumed to be highly elongated and tumbling end over end. Astronomers also noticed a slight acceleration away from the sun, larger than seen for asteroids and more characteristic of comets. When comets approach the sun, the water and gases ejected from the surface create a glowing gaseous coma and release dust in the process. Typically, dust left in the comet's wake becomes visible as one tail, while vapor and dust pushed by light pressure from solar rays produce a second tail pointing away from the sun, plus a little inertial push outward. Other compounds, such as entrapped organic materials and carbon monoxide, also can be released. But some people think Oumuamua is an alien spaceship. Is that true? Scientists have been puzzling over Oumuamua, but its flattened, elongated shape and the way it accelerated on its way through the solar system set it apart from conventional asteroids and comets. Now a pair of Harvard researchers are raising the possibility that Oumuamua is an alien spacecraft. As they say in a paper to be published November 12th in the Astrophysical Journal Letters, the object may be a fully operational probe sent intentionally to Earth's vicinity by an alien civilization. The researchers aren't claiming outright that aliens sent this space body, but after a careful mathematical analysis of the way the interstellar object sped up as it shot past the sun, they say it could be a spacecraft pushed through space by light falling on its surface. Or as they put it in the paper, a light sail of artificial origin. Who would have sent such a spacecraft our way, and why? It is impossible to guess the purpose behind Oumuamua without more data. Avi Loeb, chairman of Harvard's astronomy department and a co-author of the paper, told NBC Newsmock in an email. If Oumuamua is a light sail, he added, one possibility is that it was floating in interstellar space when our solar system ran into it, like a ship bumping into a buoy on the surface of the ocean. What do scientists think about this unknown space object? Let's delve into the details that they've gathered. Studying Earth's first interstellar object, Loeb and his collaborator, Shmuel Bayali, a postdoctoral fellow at the Harvard-Smithsonian Center for Astrophysics, acknowledged that the alien spacecraft scenario is an exotic one. And perhaps not surprisingly, other space scientists have strong doubts about it. Seth Shostak, a senior astronomer at the SETI Institute in Mountain View, California, has stated that while it is ingenious to suggest that an object the size of Oumuamua could be sent by aliens to another star system using a solar sail for power, one should not blindly accept this hypothesis when a more mundane explanation exists, namely that Oumuamua is a comet or asteroid from afar. But Loeb called the conjecture purely scientific and evidence-based, adding, I follow the maxim of Sherlock Holmes. When you have excluded the impossible, whatever remains, however improbable, must be the truth. The truth may be hard to establish, as this alien object has left the solar system and is no longer visible, even with telescopes. In any case, Loeb said, the fact that we've observed one interstellar object like Oumuamua suggests that others may be out there, and astronomers should begin a search for them. What are we left with if the truth can't be established? People dismiss the idea that it is an alien spaceship. This one's gone forever, David Trilling, an astronomer at Northern Arizona University, previously told Business Insider. We have all the data we're ever going to have about Oumuamua. The limits of information gathered about the object left room for scientists to offer guesses about what it might be and where it came from. Those have run the gamut from comet to asteroid to a never-before-seen alien spaceship. In particular, one astronomer from Harvard University and a few of his colleagues have speculated about potential extraterrestrial origins. But nearly all other experts who have studied Oumuamua say the alien hypothesis is extraordinarily unlikely. A new study from an international team of astronomers has concluded that the space object has a wholly natural origin. The alien spacecraft hypothesis is a fun idea, but our analysis suggests there are a whole host of natural phenomena that could explain it. Author and astronomer Matthew Knight said in a press release that it was initially classified as a comet, but doesn't appear to be made of ice and doesn't emit gases like a comet would. Its spin, speed, and trajectory can't be explained by gravity alone, which suggests it's not an asteroid either. We have never seen anything like it in our solar system. It's really a mystery still, Knight said. This thing is weird and admittedly hard to explain, but that doesn't exclude other natural phenomena that could explain it. A new study published in Nature Astronomy, led by researcher Knight, has concluded that it is likely an elongated comet, approximately 820 feet long, and not of alien origin. The study analyzed all existing data on Oumuamua and found no compelling evidence to support the theory of alien influence, confirming a similar conclusion reached by Knight and colleagues in 2017. In December 2017, Dr. Loeb directed the Breakthrough Listen project to point radio antennas at Oumuamua, but no alien communications were detected. Dr. Loeb suggested that humans might initially misunderstand alien technology, comparing it to ancient cave people encountering a modern cell phone. However, Dr. Knight and his team disagree with this hypothesis, preferring to rely on known analogs unless unique evidence is found. While the true identity of Oumuamua may remain uncertain, Dr. Knight and his colleagues believe it may be the first of many interstellar visitors, with new objects potentially being discovered every year. If multiple similar objects are found and Oumuamua still appears unusual, a re-examination of explanations will be necessary. Is Oumuamua an alien spaceship? Let's take a look at Professor Loeb's book. Harvard University professor Avi Loeb proposes the shocking hypothesis that Oumuamua, an anomalous object passing through our solar system, is a light sail from an extraterrestrial civilization. Despite criticism from his peers, who argue that Oumuamua's properties can be explained by natural phenomena, Loeb is convinced that it is humanity's first contact with an alien artifact. He has written a book, Extraterrestrial, which presents his case to the public and also shares his personal story. Loeb believes that science is in crisis, and his hypothesis has sparked controversy and debate in the scientific community. While some see his idea as sensational and destructive to the field of astrobiology, Loeb argues that it is a legitimate possibility that should be considered. What really should be considered about this strange object? The baffling object that defies explanation. Interstellar objects were predicted to exist long before Oumuamua was discovered. However, Oumuamua wasn't what astronomers were expecting. It was small and unusually shaped. It didn't look like a comet, yet it moved as though it were outgassing. The leading theories involve the sublimation of either nitrogen or hydrogen ice. There is no evidence that Oumuamua was a spaceship. Oumuamua's shape was also notable. Initial measurements suggested that the object was shaped like a long cylinder with a size ratio of 10, meaning it was 10 times as long as it was wide. However, astronomers later revised these dimensions to approximately 661, which instead describes a pancake shape. Astronomers have seen similarly shaped objects in the Kuiper Belt beyond Neptune, specifically a minor planet called Arakoth, which NASA's New Horizons spacecraft flew past on New Year's Day 2019. The measurements of Oumuamua's shape and dimensions were based on its light curve, a graph that tracks how the object's brightness changed over time as it tumbled through space. Oumuamua appeared brighter when we saw its broader side. Does anything suggest that Oumuamua isn't of natural origin? Neil deGrasse Tyson believes Oumuamua is a clump of rocks. Thus, the elongated shape is from gravity pulling the rocks into a chain. However, this does not explain the acceleration. If it's not an alien, what else caused Oumuamua's strange trajectory? The hydrogen iceberg theory, the proposal by Seligman and Laughlin, appeared promising because it might explain the extreme elongated shape of Oumuamua as well as the non-gravitational acceleration. However, their theory is based on the assumption that H2 ice could form in dense molecular clouds. If this is true, H2 ice objects could be abundant in the universe and thus have far-reaching implications. H2 ice was also proposed to explain dark matter, a mystery of modern astrophysics, said Dr. Thiem Huang, senior researcher in the theoretical astrophysics group at CASI and lead author on the paper. We wanted to not only test the assumptions in the theory, but also the dark matter proposition. Dr. Avi Loeb, Frank B. Baird, professor of science at Harvard and co-author on the paper, added, "We were suspicious that hydrogen icebergs could not survive the journey, which is likely to take hundreds of millions of years, because they evaporate too quickly, and as to whether they could form in molecular clouds. Scientists have been unable to determine the origin of Oumuamua, an interstellar object that passed through our solar system in 2017. Researchers considered the giant molecular cloud W51 as a potential point of origin, but concluded that it is unlikely due to its distance and environment. The formation of hydrogen icebergs like Oumuamua is also difficult to explain through traditional astrophysical processes. The growth of solid objects typically occurs through sticky collisions of dust, but this theory doesn't hold up for hydrogen icebergs. The study found that thermal sublimation by starlight would likely destroy molecular hydrogen icebergs like Oumuamua before they could escape into the interstellar medium, making it unlikely that Oumuamua came from a giant molecular cloud. This conclusion also challenges the idea that primordial snowballs could be a form of dark matter. What other theories do scientists have? The dust bunny theory and the nitrogen theory. In the new research, Liu and her team suggested that a large chunk of rock may have once broken off the comet's nucleus, and as dust and gas particles flowed away from the nucleus, they would attach themselves to the rocky fragment, eventually forming Oumuamua. Over time, as the fragment grew larger, the gas flowing away from the comet would eventually push the dusty rock out into space. The scientists suspect the original comet was a long-period comet, which take a long time to circle their stars and travel quite far away from them. Because of the comet's weak gravity and the pressure of radiation, the researchers think that the object separated from its parent comet on a trajectory into interstellar space, eventually leading it on a brief detour through our solar system. Liu thinks that with sky survey technologies like the telescope Pan-STARRS 1, which first spotted Oumuamua in 2017, we will start to see more and more interstellar interlopers like Oumuamua, according to a statement. The Pan-STARRS 1 telescope in Hawaii, nestled high atop the summit of Maui's Haleakala volcano, is a space rock hunting powerhouse that can see extremely faint objects like Oumuamua. Observing new interstellar travelers is vital, as the fast pace of Oumuamua means scientists were only able to observe it in our solar system for a few weeks. By spotting new objects, scientists could also see whether they formed in the way that Liu's team proposed in the new research on Oumuamua. What does the nitrogen iceberg theory say? The nitrogen iceberg theory stated that Oumuamua was likely debris from a Pluto-like planet in another solar system. In their latest study, titled "The Mass Budget Necessary to Explain It as a Nitrogen Iceberg," Amir Siraj, Avi Loeb, offered an official counterargument to this theory. According to their new paper, there is an extreme shortage of exoplutos in the galaxy, which explains the detection of a nitrogen iceberg. In the paper where he broached the possibility, Loeb indicated that Oumuamua's unusual character and behavior were consistent with a solar sail. This included the highly reflective nature of the object and its profile, which appeared to be either cigar-shaped or pancake-like. More importantly, its sudden acceleration and deviation from its expected orbit appeared to be the result of radiation pressure, which is precisely how solar sails achieve propulsion. In their first paper, Jackson and Desch addressed the size and compositional constraints of Oumuamua and showed how its albedo was similar to the nitrogen ices on the surface of Triton and Pluto. In their second paper, they showed how these types of nitrogen ice fragments could be generated by the collision of extrasolar objects similar in composition to Pluto and Kuiper Belt objects. By their estimates, these collisions would generate and eject around 100 trillion objects into interstellar space, half of which would be composed of water ice and the other half of nitrogen. This population would be enough to satisfy the statistical significance of ISOs necessary to explain the detection of Oumuamua. Equally important was the fact that an object composed of N2 would not form a tail as it neared our sun, as there would be no water vapor or oxides of carbon to sublimate. Where does this discovery take us? Oumuamua and the cosmic radiation. Now, a University of California, Berkeley, astrochemist and a Cornell University astronomer argue that the comet's deviations from a hyperbolic path around the sun can be explained by a simple physical mechanism likely common among many icy comets: outgassing of hydrogen as the comet warmed up in the sunlight. What made Oumuamua different from every other well-studied comet in our solar system was its size. It was so small that its gravitational deflection around the sun was slightly altered by the tiny push created when hydrogen gas spurted out of the ice. Most comets are essentially dirty snowballs that periodically approach the sun from the outer reaches of our solar system. When warmed by sunlight, a comet ejects water and other molecules, producing a bright halo or coma around it, and often tails of gas and dust. The ejected gases act like the thrusters on a spacecraft to give the comet a tiny kick that alters its trajectory slightly from the elliptical orbits typical of other solar system objects, such as asteroids and planets. When discovered, Oumuamua had no coma or tail and was too small and too far from the sun to capture enough energy to eject much water, which led astronomers to speculate wildly about its composition and what was pushing it outward. Was it a hydrogen iceberg outgassing H2? A large, fluffy snowflake pushed by light pressure from the sun? A light sail created by an alien civilization? A spaceship under its own power? Jennifer Berner, a UC Berkeley assistant professor of chemistry who studies the chemical reactions that occur on icy rocks in the cold vacuum of space, thought there might be a simpler explanation. She broached the subject with a colleague, Daryl Seligman, now a National Science Foundation postdoctoral fellow at Cornell University, and they decided to work together to test it. A comet traveling through the interstellar medium basically gets cooked by cosmic radiation, forming hydrogen as a result. Our thought was, if this was happening, could you actually trap it in the body so that when it entered the solar system and was warmed up, it would outgas that hydrogen? Bernier said. Could that quantitatively produce the force that you need to explain the non-gravitational acceleration? Surprisingly, she found that experimental research published in the 1970s, 80s, and 90s demonstrated that when ice is hit by high-energy particles akin to cosmic rays, molecular hydrogen is abundantly produced and trapped within the ice. In fact, cosmic rays can penetrate tens of meters into ice, converting a quarter or more of the water to hydrogen gas. How do we get more information on Oumuamua? Daring mission to investigate this unknown extraterrestrial object. So they don't know for sure what Oumuamua was: a shard of an exoplanet, a comet spawned by another star, an alien spacecraft? It is now outside the range of earthly telescopes, never to be seen again, or is it? A team of scientists in January 2022 said they wanted to build a spacecraft to go after it. They claimed they could reach Oumuamua as early as 2047, and they called their effort Project Lyra. It's worth noting that so far, astronomers have only discovered one other interstellar visitor, which they call 2I Comet Borisov in 2019. The 2I stands for Second Interstellar. Borisov was very clearly a comet, and Oumuamua might be a comet too, but the situation isn't as clear with the baffling object. Its true nature is still up for debate. So in terms of a target for a spacecraft, Oumuamua would be an interesting place to start. Initiatives do exist for proposed missions to neighboring stars. So why go to Oumuamua? Proponents of the mission point out that objects such as Oumuamua and Borisov are much closer to us than stars. So they offer us a chance to observe interstellar material close up, if only we can catch up to them. The Initiative for Interstellar Studies formed Project Lyra just 11 days after Oumuamua's discovery. The team has had the challenging task of assessing the feasibility of an exceedingly fast spacecraft. It would have to travel many times faster than the fastest spacecraft. To catch up to Oumuamua, the spacecraft would need to travel at speeds of 74,000 to 163,000 miles per hour. The spacecraft could use traditional chemical engines paired with flybys to catch up to it. That is the system NASA often uses for planetary spacecraft in our solar system. The scientists have also considered laser propulsion and solar sails, two methods of space travel that are currently in experimental phases. How do we detect other interstellar interlopers? The great potential of the James Webb Space Telescope. On October 17th and 18, 2017, an unusual object sped across the field of view of a large telescope perched near the summit of a volcano on the Hawaiian island of Maui. The Pan-STARRS 1 telescope was designed to survey the sky for transient events, like asteroid or comet flybys. But this was different. The object was not gravitationally bound to the sun or to any other celestial body. It had arrived from somewhere else. One of the most exciting findings in planetary science in recent years is the discovery of interstellar objects passing through our solar system. So far, astronomers have confirmed only 2 of these interlopers from other star systems. 1I/Oumuamua in 2017 and 2I/Borisov in 2018, but many more are thought to exist. Scientists have had only limited ability to study these objects once discovered, but all of that is about to change with NASA's James Webb Space Telescope. Dr. Martin Cordner, principal investigator of the Webb Target of Opportunity program, has emphasized the significance of the James Webb Space Telescope in investigating the chemical composition of interstellar objects. This opportunity allows scientists to gain insight into the origin, formation, and nature of these objects, as well as the conditions present in their home systems. Dr. Cordner, an astrophysicist at NASA's Goddard Space Flight Center and the Catholic University of America, considers the ability to study material from another planetary system up close to be truly remarkable. His team aims to determine the uniqueness of the first 2 detected interstellar objects, which exhibited different characteristics, and whether they represent the broader population of interstellar objects. Thank you for watching. Do you think we can catch up with this speedster? Comment to share what you think in the comment section below. Remember to like and subscribe to see more videos.